Okay, so if you have scanned the QR code, you should have access to this novel example. I'm going to show you how to get started. It's super easy, and all you need is just right click, open this one in Google Colab. Then you can install the packages. Then you can go through. It's all free, and you don't need to pay anything. You don't need any API key or anything. But later, if you want some more advanced features, it does require a MapTiles API key, but it's free. You can also get one. I'm going to show you how to do that later. So if you open that in Google Colab, then you can just uncomment the first code block to install Leafmap. So let me run this one quickly here. Run anyway. Give me a little bit. Oops. Typo here. So it might take a couple seconds to install the package. Again, if you want to learn more about Leafmap, you can check out the website. So this is a package I created, I think 3 or 4 years ago. The goal is to make it easier for people to create maps in a Jupyter Notebook environment, and then allows you to visualize all kind of geospatial data. And so you don't have to learn so many libraries. Just like if you're doing deep learning, there was PyTorch, TensorFlow, and some other deep learning framework, right? But I mean, the goal is the same. It's to deep learning. So, and they all have different syntax, different API. So Leafmap is kind of very similar, but it's the mapping space. There are different mapping libraries out there, and they all have different syntax. It's kind of difficult for beginners. So I created this package to make it easier that you can use different libraries in the same API, but you can just switch the backend, and then everything, the source code looks the same. But you can change, like, okay, this source code, I want to use the PyTorch backend, I want to use the TensorFlow, so you can switch that easily in Map. So once you install the package, then it's pretty simple. You can just import the libraries, and so this is where the backend comes from. So for this tutorial, I'm going to show you how to use the MapLibre, because it has a lot of 3D mapping functionalities. But you can also use Folium, use IPyLeaflet. There are some other mapping libraries out there. So, and that's it. Once you import the libraries, then you can just create a map. So leafmap.map, and that's it. And by default, it's going to have this kind of map here. It looks pretty boring, but actually there are a lot of functionalities. You can change this one to a 3D globe. So you can change from 2D to 3D easily. So if you're dealing with data at a global scale, it would be much nicer to have this kind of 3D, because it doesn't have distortion. You don't have to really worry about the projection. Also on the right here, there's a button. You can click it, and then allows you to change the opacity on the data layer. So basically this one allows you to actually interact with the map. And later I'm going to show you how to actually visualize all kind of geospatial data, raster data, vector data, 2D, 3D. So there are a lot of things you can do just with a couple lines of code. So you can play with it, and also you can click the button here. If sometimes you have some widget you want to make it larger, you can also change this to make the widget much larger. So everything is very interactive. You can close it. You can even remove the data layer if you don't need it. So this is basically what Leafmap is about, is allow you to create maps easily, and you can interact with the map easily. The only thing that's not working in Google Colab compared to running JupyterLab is this full screen button. So if you click on that, this one won't work. Okay, so this is just the security limitation of Google Colab. Other than that, everything else pretty much is the same. So going forward, I'm going to switch to my local computer here. I'm going to use my JupyterLab. It's much more smooth rather than using Google Colab. Google Colab is great, but sometimes it's not as smooth. So I'm going to use this. I'm going to open my local Jupyter environment. And so let me switch to the Leafmap notebook. Again, the same step. I have already installed the packages. So let me quickly, oops, the other one. So once you get access to notebook, install the package, and then just import the libraries. And I highly recommend that you play with it yourself. You will see how easy it is to create this kind of maps. Like I said, right now this is on my local computer, so I can actually full screen maximize it if you need more space. and this globe button allows you to change that to 3D map. So, and this is all you need to write, 2 lines code, and that's it. And you can also customize the center, the zoom level, the pitch, and also the bearing. So basically let me change this one to without the 3D globe, just the 2D. So the center, basically the longitude and the latitude, the zoom level basically is from 1 to 24. So the smaller the number, you are getting the overview of the globe. The larger the number, the more detail. For example, it changed to 12. You want to see more details here. You might need to zoom out. So this is just the background-based map. And the pitch is basically the direction that you're looking at that, just like horizontal, for example, if we change to 60 degree, it's going to look like this. Right? So if it is 0, that means it's overhead looking from the top to the surface. And also the bearing basically is the angle between the nodes, right? So if you, for example, I can change it to maybe 90 degree. That means you are shifting from the nodes to the, you might need to zoom out a little bit so you can see the in here. So right now the US is pointing to the west because I have 90 degree. But you can always press your control key and then you can drag the map around. It's all up to you how you want to turn it. So you can also change it to 3D globe mode, and then you can switch the map. You can drag it around, and you can see all the labels. So this is called so-called vector tile. Vector tile means the data is vector data, and so it's vector tile basically means the resolution is really high. Unlike if you zoom into Google Earth, right? Sometimes you're going to see the pixel when you zoom too much. But for vector tile, you're never going to see the pixel because it's rendering as vector tile. So it's super sharp and crispy. So this is just the simple steps to create the map. And next, let me show you how you can change, for example, different base map. There are a lot of base map available. So by default, it's using the dark method, but you can change the style to position. So this is all free. You might see it's like, it's all white. There's not much information. But if you zoom in, you will see a whole lot more details. So actually, this is built on top of OpenStreetMap, so you can actually see a lot of information in there. So this is just 2D. And the other one here, this is the more recent one, free, using the Liberty style-based map. And you can see, again, this looks like Google Map, but it's not. It's free and open access. The difference is that just with 2 lines of code, I can create 3D maps. So you can press Shift on your keyboard and then just drag a rectangle. You will be able to zoom into a location. So you can basically create a map like this. And the nice thing about this data set is actually 3D. So I can zoom in, and then once you see the buildings, press Control on your keyboard and just drag your mouse. Look at this. Right? How cool is it? And all you need, 2 lines of code. So you can create 2D, 3D. You can switch to 3D. If you want the 3D. Of course, you need to zoom out a little bit if you want to see the 3D. Otherwise, it's not going to be super clear, right? So this is how you can create maps. And it's all free, open access. You don't need to pay anything, free license. Anyone can use it. So this is super powerful if you want to create some maps in a Jupyter environment. You can also deploy as web app. So right now, basically, I'm showing you here in a Jupyter environment, but I also have some, applications on the web. So I can show you quickly. Just turn your application into a web application. So other people, they don't have to use Jupyter. They don't need to know coding. You can just send the link to them, and then they will be able to have access to the same information. So this is deploy basically the application is a web app. So you can, again, you're welcome to go to the link, and the same thing here. I can create maps. I can have different sidebar, and there are not many lines of code you need to write. Right? This is the same thing I'm showing you earlier. And you can even visualize 3D vector data, raster data. So we have all kinds of geospatial data. So you take a look at this, and you can change the opacity, turn it off, and you can even overlay satellite data on top of that, and you can see what's the differences. So this is what we get from the satellite or drone imagery or area imagery. It looks like this. And you also have all those different angle, different orientation. But these are kind of geospatial data building on top of the base map, and you can see how you can customize it. Everything is customizable. You can add layer, you can remove layer. There are a lot of things you can do, and you can even overlay, for example, video. I will show you the source code behind how to, for example, overlay a video on top of the base map. So and you can see this is the drone imagery. You can see the wave like moving around, and nice thing, it's all interactive. You can turn the layer on off. I can change it, and it's 3D. So I can actually, if I want, I can have the terrain, and I can overlay the video on top of the base map. And again, it's very simple, easy to use. There are not many lines of code in it, right? Everything is open source. So for example, for this particular video, look at this, just couple lines of code, and you can create a map. You can visualize that. You can go to the website to take a look at it. Anyway, I just want to show you some of these applications. So you can do things in a Jupyter Notebook environment, and then you can also translate this one into a web application or dashboard that other people don't know how to code. They can also use your stuff. So it can help you basically make your products more accessible to the general public. Okay, any questions so far? Yes. QR code. So here is the so here is the link to the QR code. And for the web app, I don't have that on the map, but you can just search my name and then Hugging Face. You should be able to find it. So Hugging Face /GISWQS, and you can see some of those web apps that are created that you can easily adapt and then to create your own applications. Any other questions? Yes. What do you mean? What animation? Not directly, but if you can create a map, if you want to like create a video, I just use the screen recording OBS Studio, and then you can just create I have all kind of demos that I put on GitHub, so you can create all kind of animation that you want, short or long one. So if you go to, for example, let's see here, YouTube.com. Yeah, you can search, go to my YouTube channel here. I actually have 100 videos, so you can have all kind of video, short demo, like something like this. So you can just use the regular video recording software to just record, and you can showcase, and you can speed it up or something like that. But the map itself doesn't have functionality to actually export the animation, but you can write source code to be able to do that easily. Any other questions? Yes. Yeah, you can. It's up to you. So you can design a program. So if your program doesn't really interact with the map, you can just do batch processing. But if you have something you want to pass the information, for example, if I develop an app that I want to allow the user to select something and then run the computation and then pass the back result as a map or something, you can do that easily. So for example, here, assume that I create these map applications, and assume that you have some data you want to show on the map based on the user input. You can do that. You can add a draw control, or you can maybe add the event handler to the map, and then you can actually get the location. For example, right now, let's say I click somewhere here, right, my mouse. You can actually get the location of this, the one the user clicks. So for example, map.click. You're basically pass back the coordinates, or you can add the draw control. You can actually get the bounding box. So most of the map actually, especially when you look at on the right here, right, these things all allows you to change things interactively. You basically can design a widget, allows you to interact, and then you pass those user input into the map to run visualization or computation. So that's one way. The other way is you allow the user to interact with the map, and then you pass the information back into your program to do things. So basically, it's like bi-directional. There are a lot of things you can do, because under the hood, this is built on top of iPi widget. So iPi widget basically is synchronized between the front end and the back end. So there are a lot of things you can do. You just need to think about what do you want. Then there will be something that allows you to actually connect the Python and also JavaScript together. Okay, so this is about just create a map. So as you can see, it's pretty powerful. Just with 2 lines of code, you can create 2D, 3D maps. But you can also allow you to maybe add more controls, like geolocate control. For example, I can click and you can actually zoom to the location where I am right now. Of course, it depends on your Wi-Fi. It might not be super accurate, but this is one way. And you can have the full screen control like this. You can zoom in and zoom out. Or you can have the navigation control to basically zoom in the map, zoom out the map, and also everything you can just press control on your keyboard and then you can drag the map around. Again, on the right here, this one is hidden, but it allows you to control the map, turn all the layer on, off, or something like that. And the door control, yeah. So this is the one that I mentioned, right? Assume that you develop some applications and you want to show some data based on the user input. For example, the user can draw a rectangle or something. You can do it easily. So I can, for example, click here. Okay, this is my study area. This is the one that I want. And it might not be accurate. You can actually drag it and actually can modify the ROI if you need it. So once you have this, you can actually, for example, you can design a widget, have a button somewhere, some here, and then say display the data beneath that. You can do that because the map can get the information that you created. So for example, if I select this one, you'll be able to see all the coordinates that the user created. You can get the entire feature collection. So basically, you can get user input from the map and then use that to run some program or algorithm that you design. And once you return the result, basically it's a callback, you can pull the data back on the map. Make sense? So basically it's like depends on what you want. There are a lot of things to pass back and forth between the map and also the user input. Okay, so that's basically about creating a map and 2 lines, 2 3 lines of code. But you can also add base map. So just 1 line of code, I can add, for example, open topo map. It's not showing up. See here? Oh, it's coming. Okay. Yeah. So this is like there are a lot of base map available, similar to Gmap, allows you to add base map, and so you can change the layer, opacity, something like this. So we have raster layer, we have vector data layer. I'll show you. You can remove the layer if you don't want it, and you can add other base map imagery. For example, the Esri wall imagery. So this is something that you can utilize, or you can even do this. Just create a map, and then you can just call this map.addBaseMap. If you don't provide anything, then it will show you this drop down list. So from here, you have hundreds of base map to choose from. So you can change any base map that you like. For example, let's say, okay, I want the Esri maybe National Geography base map, right? You can just change it and then you will load it up. Then you can zoom in to see more details. This is very responsive and it's very fast, especially if you have a fast internet. It's super nice, and you don't need to do a lot of coding. Just create a map, add some layers. That's it. You also support a lot of other data layers. So in GIS, WebGIS, we have so-called this like MapTiles. So basically, it means they have a server. You are rendering the tile, kind of like Google Map, right? So behind the scenes is actually you have a lot of smaller tiles transporting from the server to the client. And so you're going to have, if you have something like URL like this, then you can easily load it to the map. So for example, this is a web-based base map from USGS. So you can put the data layer in. I can add some WMS layer. So they basically have different web services available that allow people to render the map. So this one is using the WMS. Not sure it's not why it's not coming out. Okay, it's coming out. It's just a little bit slow. So for example, you might have some drone imagery, for example, for your study area or for an area of interest, right? So you can actually have the data on the server and then you just use the web app to actually to render it. And this is pretty high resolution. For example, this is like sub-meter level, sub-meter resolution imagery, very high, and you can just load it on the map, and you can change the opacity. You can zoom in to see more details. So basically, Leafmap allows you to bring in pretty much any geospatial data. It doesn't mean it's vector data, raster data, MapTiles, all kinds of different types. And so, for example, I can load the national wetlands inventory from the US Fish and Wildlife Service. So all I need is just basically the URL, and then I can just add the data layer, WMS, and this is all the wetland data layer. So you can zoom in, you can see the legend here, and I can change the opacity, right? So this is what it looks like on the ground. And this is national scale data set, and I can change it, right? And you can see all the wetlands polygon. So pretty much, if you know the data being hosted, if you know the URL, you can load the data in, and it's not very complicated, right? You can pass in the data layer, add the layer control. So basically, it's this one on the upper left corner here, and then add the legend. So the legend basically is the one in here. So pretty much everything is just one line of code. And you can think about the map just like a Lego block. You can get things in, you can remove things. So it's very, very flexible, allows you to do a lot of things. All right, so that's about create a map, add some data layers. And it does have the 3D globe, but it doesn't really have the 3D terrain. So in order to do that, we need some base map that has the 3D terrain, 3D topography. And for that one, I would recommend using the MapTiles. It's a commercial company, it's a company, but you can get the license API key for free. So if you're interested in some of the more advanced functionality that I'm going to show you, you're welcome to click the link, and then it will take you to the website, and you can log in using your Google account. And once you are there, they have some of the base map in here. So all you need to do is just to go to the API key here, and then you should have API default API key. Again, don't expose this one to other people because they can abuse your account. I'm going to show you here. It doesn't matter because you can click the replace. You will change the API key right away. So it doesn't really matter. So for example, here I can replace API key, and then you can just copy this one here, Control C, and then I can come back to here, just uncontrol this code block, and then change this one with your API key. Or you can select as an environment variable. So if you already know Python, that's pretty easy. So the power of this is you have access to a lot more base map data layer. So with that, now I can show you what you can do. So with the same line of code, for example, let's say the 3D satellite. So all I need just, So with this, I can just add, let me restart the kernel. Something might be messed up. So I'm going to go back to import the libraries, and then I can go to the MapTiles here. Is it the big one? And then let me do this. Okay. Yeah, it works. So as you can see, you just set the API key, and then you can just use those base map. The style, for example, can be street, can be satellite. I don't think it's coming up. It's working this morning. So let me replace this one again. Yeah, not sure if this is the internet or the API key problem. So let me restart here. I do want to show you because it's very cool compared to just the 2D. And let me start here. And oops. I think I already have the API key on my local computer. So let me try this way, see if it works. And train. Okay, yeah. So I think it's just the API key problem. Anyway, so this one allows you to actually access the MapTiles 3D map. It's a little bit slow, but allows you to see. This is just the terrain, but it should have the base map loading up. It might be just the internet. So you can see the topography. So behind the scene is basically have this terrain, and then you have all other data layers that can drag on top of the 3D terrain. Let me try the other one, see if it works. Okay, so this one looks like works better, but I think it's just the internet. All right, so take a look at here, right? I set the center, the zoom level, the pitch, and also the style 3D satellite, and that's it. So with this, I can zoom in, zoom out, you can rotate. So you can see all the imagery in the 3D globe. And you can also turn this one on. It's actually just a 3D. If the internet is faster, it will be so much better. So you can see here. And pretty much everything can create it. Just 2 to 3 lines called create a map, specify the globe, and add up some other data layers, and that's it. So you're welcome to try out these different base map data layers. And the next one will show you is you can render some 3D buildings. So let me show you, create a map, and then I can here. It might be just the network is not working very well. So you're supposed to see a map like this. You have 3D buildings overlay on top of the base map. Yeah, right now the API is not working. Let me try something else. How about this example? So for example, if you have some data for indoors, and so these are all the geospatial data basically representing the boundary of the object. But if you have some height attribute, so you know how high it is, yeah, you can actually render the data on the map. So for example, I have this GeoJSON file, looks like this. So this would be the traditional maps, interactive map, and you can see the basically the floor plane like this, right? So you're basically looking from the space overhead and then seeing that on the ground. But it's not super useful if you want to see some 3D. So you can actually convert it to 3D. But what you need is like height attribute. So if you know the height, and you can actually turn the map into something like this. Right, so earlier it was like this. And because the attribute is the map has the, for example, the color, so you can actually render the map based on the data, based on the information from the data. So take a look at this. I can create a map, and then you can convert it to a 3D map like this. And very simple. So all you need to have some kind of data that you can play with, and you can customize, create a map. So you have some indoor application, for example, you're trying to help people navigate inside the building. This can be pretty useful. Once you have the data, then you can just create this kind of 3D floor plans. And it's not that complicated. 1, 2, 3, 4, 5, basically 5 lines called create a map, get the data, add the data to the map, display the map, and that's it. So this is how we can render vector data. And next, I'm going to talk about raster data. So this is where all observation data play a role here. Is we have a lot of satellite data, and satellite data is not something you can directly open using a file explorer on your computer, because you need some specialized software to actually read the data. By using a Leafmap, it's very easy. Just tell you where the file is located, and then you can do it. So for example, I have this file hosted on GitHub, and I can download the file to my computer, but you don't need to. If you can certainly do that if you want to. So I can download this sample file to my computer, and then so all I need to do is just create a map, and then just use the .add raster. So raster means I'm going to let this geotiff, and then that's it. So let me show you here. So once you load it, it should automatically load it, zoom into the data, and see how easy it is. So now I can actually render the raster data set on the map easily, just one line code, add raster. Yes? Yes, I didn't have the example here, but in Leafmap, it has that functionality. So let me show you. If you go to the Leafmap website, and if you go to, I think there's a notebook. Let me search it here. There's an example exactly what you're looking for. So tutorial, Control F, time slider. So there's a use time slider, the visualizing time series images. So you can see something like this. And there will be time slider allow you to drag through that. As long as you have the file path or the URL, you can do it like this. So it's actually pretty flexible. And all you need basically is just construct a dictionary of all of those data layers, and then you can use the time slider to do that easily. Yeah. And again, this is just a satellite-based map, right? And you can change the opacity. You can turn the layer on and off. So it's very easy. Like I said, if you're new to Geospatial, you might be like wondering, okay, how do I see this file? How do I see that? Leafmap can read pretty much any raster data set, and then just render it on the internet map rather than open it as a JPEG or PNG on a computer, because Geospatial data is much larger. So most of these files can be 1 gigabyte, 2 gigabyte, 10 gigabyte, but you can load the data to the map easily. So the thing about this, why you can load the data so quickly, is it doesn't load all the data into the memory. So basically it's constructing the tile. So when you are zooming, you just grab the small tile, you see more detail. When you zoom out, it's just a lower resolution. And so this is where all the geospatial data are being utilized in the web mapping. For example, if I zoom in, you will see, depending on the internet, you will see it becomes a high resolution, right? So you don't see it right away because it's doing all the calculation, and it's going to figure out which tile is going to be rendered and then pass it back to the program. So, and again, if you have any geospatial data, all you need just one line code, add raster, that's it. And then you will load the raster. And you can change the band combination, the indices, how you want to visualize that. I can render like single band raster, because for satellite data, most of those are like multispectral band. So we can actually render a TIFF. Again, just the internet is very slow, but if you run it on your own computer, it should be much faster. So I have downloaded this DM, digital elevation model, and then I can create a map, just add raster and see how it works. So you zoom to the map, and now I have this. So similar to earlier this morning, I show you how to use Google Sensing, but you can do that without Google Sensing. So I have the file on my local computer, or it's in the cloud. You can just render it, and this is all free, so I don't need to pay any services. So you can render the map. I can change here. I can change the opacity. So you can basically customize to whatever you like. And you can change the color map. If this is not the color map you want, you can change to anything, right? I can say maybe cool warm. So any color map supported by MapLibre, you can do it easily. So just run it. Now I have a new map showing up in here. So it's super powerful. So it can help you render data really easily. And the other one is cloud optimized geotiff. If you are in geospatial, you might have heard about it. But in non-geospatial people, cloud optimized geotiff might be new. But basically, it's a geotiff file with some spatial things in the header, and you can put the file in the cloud, and then you can actually request the data on demand. So it's going to figure out how much data need to be transported from the server to the client, and you can host the data somewhere in the cloud. So this is what it looks like. Just see here, I have 2 files hosted on GitHub, and it's basically just a file like in the release. You don't have to download the data. So these 2 files can be like 100 megabytes. It doesn't matter how big it is. I don't have to download them. I just use the function called map.add cog layer. Give me the URL and then pass into this function, and then that's it. Now I have these 2 data layers. So take a look. These are the 2 data layers covering Libya. I think was because of the flooding. So you can see here the damage of the buildings because of flooding. And the nice thing about this is because it's multi-data layer, right? So I can have this. I can turn the layer on and off. So you can see what it looks like before the flooding. This is what it looks like after the flooding. And you can change the opacity. So it's really responsive and it's really fast, and you can pretty much load any data that you like. And as long as you have some data, either it's single band, multi-band, you can do it like this easily. So this is how you visualize satellite imagery, DEM, all kind of remote sensing data. The other data type I want to cover is called STAC. STAC stands for Spatial Temporal Asset Catalog. It's a very long name, but basically what it means is this is a protocol for basically organizing the data, so makes the data can be discovered or queried using some standard protocol. Rather than if you, for example, you just dump some satellite data in the cloud on GitHub, people cannot really search it. You need to know the exact URL, so it's not very convenient. But this one basically is treated kind of like a database. You can query by location, query by time, but if you have the URL, you can also render it. So for example, this one have a spot imagery covering, for example, Canada, and it's a couple hundred megabytes. And then you can just specify, okay, I want to add this data layer. I want to have add these 2 spectral bands, and the chromatic band, and also the B4 to 3. So that means it's the multispectral. So you can see here, and this is a landscape imagery hosted in the cloud with couple hundred megabyte or gigabyte, doesn't matter, and you can load the data directly. Although right now it looks a little bit fuzzy because the internet is a little bit slow, but if they faster internet, you should be able to see that load up very quickly. And then you can see I have 2 data layers here. This is the panchromatic band, and this is the RGB band. So allows you actually to visualize pretty much any geospatial data that you want. Either it's locally, it's in the cloud, you can do it easily. And you can also load data, for example, from Microsoft printed computer. So you may have heard about Google Sensing. So Microsoft also has I used to call it a cloud computing platform, but it's not anymore, because Microsoft printed computer used to provide a Jupyter Hub for free, but they discontinued that last year. Pretty sad. It's kind of similar to Google Colab, but it's for geospatial, but for whatever reason, they discontinued. But they still have the data catalog. So it's still pretty nice. So you can still use the data catalog to retrieve data. Compared to Google Sensing, this one is like you have much more control. It's more rapid and more open. So you can actually download the data if you want to. And Leafmap basically allows you to also visualize the data directly from Microsoft printed computer. So you can load the data easily using the map without having to download the data. So basically allows you to stream the data from this kind of cloud platform. For example, this is a landscape imagery again, more than 1 gigabyte. We can load it easily without having to download the data. So you can overlay on top of the base map, makes it really powerful. So basically allows you to visualize data from a local computer, or it's the data from a third-party provider, or it's the data hosted somewhere else. And the nice thing about the GOT is cloud optimized is you don't need a server. You just need a static hosting. So you can put the data on anywhere as long as it's accessible to HTTP URL. You don't need to have a spin up a server to really to render the tile. It can be anywhere as long as it's accessible through HTTP. So basically you can put it on S3 bucket or Google Cloud Storage, or for all the example that I show you, I just dump that on GitHub. I don't need to actually. So imagine if you have tons of data. So for me, I use Hugging Face because it has like pretty unlimited data storage. So it's just basically a gig repository. So you can see I download my data here, and that's it. I don't need to host the data on my own server. I just dump all my data in here, and my map can actually render the data. So for example, I can show you maybe how about maybe look at this. For example, net RGB train. For example, I use a lot of data for doing training the models. Like just put the data in there, and all I just need this URL. That's it. So I can copy the URL, and then I can come back to my map. So I don't care about anything of this. I can remove it. I just create a map, and I will show you how easy it is to put the data loaded from the Hugging Face. So just put in the URL, double quotes, and then if the URL, and the next step would be just map.add cog layer, and then URL. If you use Python, I guess you can pretty easy understand the source code that I'm running here. So it's pointing to this URL, get the code layer again. Depends on the internet speed. Sometimes the endpoint might be a little bit slow, but I guess it should come up. Otherwise, so basically what I'm doing here is I use this URL, and then I also have a T-tiler endpoint here on Hugging Face. They can render the tile, and then I pull the tile from Hugging Face to my web applications. So I'm actually using this, where is it? Let me see here, T-tiler endpoint. So basically this is the middleman where, oops, it might be down or might be, no. Anyway, so the tile actually come from here. I might need to reboot it. Anyway, you get the idea. It's all free. So I just utilize all the free resources. I put the data in the free storage. I created this mid-domain server. It's free. So, and then I have this map applications. So if I need to render the data, I send this one to this mid-domain and then put the tile from here, because you cannot directly just put the data on the map, because you need some, without that, when you zoom in and zoom out, you need to load the entire data. But with the tile server, it's going to calculating what tile need to be grabbed and then passing into here. But it's free, so you can try it out if you want to. And you can also export the data as HTML. So once you create the map, not export HTML, just add any HTML elements to the map. So if you have the map, you want to showcase something, emoji, text, images, video, you can just call the function map.add.html, very easy, and then you can load something to the map. You can add anything that you like. So like the map is basically just a Lego block. You can add anything you want to the map. Okay, so that's about some of the things you can do. Any questions? Yes? So actually I have example data, so it's open access, so you can get the entire global buildings for free, and you can render it on the map. It depends on what format you're handling, so you can use GeoParquet, so basically a columnar data format. You can also use so-called PMTiles. So PMTiles is similar to the cloud optimized GeoTIFF, but it's for vector data. So basically it's just a single file, same thing, host it, put it on Hugging Face, and then you can render it on the map as well. Yeah, OpenStreetMap, they don't really provide the PMTiles. So OpenStreetMap has lots of data, is free, open access, but the data format is not something you can easily render in 3D. So there are other people building on top of the OpenStreetMap, convert it to basically a vector type format, allows you to actually consume this one web applications. So one thing that if you're interested in, you can search it called PMTiles. So basically it's like a portable map tiles, and it allows you to render massive scale, so like global scale data, hundreds of gigabytes, and you don't need a server. You just put it somewhere on a cloud storage, and then just expose a HTTP request. Then you will be able to actually render the data on the map. I will show you the examples shortly. And so I have a couple more examples here about the map tiles. I think might be because I there's an error. Let's see if this one works. Okay, it works. So basically my mid domain is still working fine. So for example, I have this DAM, digital elevation model, right? And you can actually load the data layer, and you can also add a color bar here, color map. So kind of using the MapLibre, MapLibre color map, right? So you can add, basically you can add different components to the map easily, right? I have this one, and you can clearly show the elevation from 0 meters to 1,500 meters. So this is low elevation, and this is high elevation. So basically you can load the data, but you can also add something to that. I can also maybe change the color bar to be maybe transparent. So if you need transparent, you can do that. So everything is just using one line of code. And the last one here is I can change it to vertical. So if you have, and this is particularly important in geospatial because there are so many different types of data and they all represent different things. So it's nice to be able to actually add a color bar to represent the continuous, basically the range of values for your data, so people know which one is high value, which one is low value, what's the value range. It can be elevation range, it can be temperature range, it can be population, whatever, anything. So it allows you to actually add these kind of components to the map easily just using one line of code. So you don't have to worry about how do I create HTML, how do I do that. Very easy. So the next one is about legend. So it allows you to create a legend, for example, something like this. So especially if you're dealing with lane cover data, you want to know, for example, what color represent what lane cover type. So you can also create something like this easily. Again, one line of code, just add a legend, or you can also customize it if you want to. So it has lots of examples here. You can customize a dictionary, and this is the one being used to render that on the map. So for example, if you don't like the name, you can customize it. For example, let's say this is open water. You don't need open water. I just change it to water. You can just change it, run it again, then you can have water. So everything is easily customizable. Okay, so that's about adding legend, and the next one is about adding video. So I showed you earlier in the web app, so it's pretty easy. Create a map, and then you can specify where your videos are hosted, and then specify the coordinates. Where do you want to put the video on top of the map? And then just one line of code, add video, that's it. And passing the coordinates with that. And let's take a look. So if you have some drone video from UAV or whatever, you can create a map, you can load it on the map, and then it looks pretty cool. I think the internet traffic is pretty bad, so it doesn't show up. Usually it should be pretty quick. If you run it maybe on your computer, it might be a little bit faster. It might be just my computer problem. Anyway, so this is just some of the way that allows you to add geospatial data, but you can also add a lot of non-geospatial stuff. It can be video, it can be images, it can be HTML, it can be text, it can be anything pretty much. You can add it to the map as some kind of a map component. Okay, finally it comes up. See here, this is just a simple things that you can render on the map, and you can actually see it. It actually aligns pretty well with the base map, and I can press Control on the keyboard and you can drag it. If you want to make it even better, you can actually render it on a 3D. Right now, this looks like 2D, but you can actually render it on a 3D. So all I need to do is just, let me show you here. I think because the map title is not working, otherwise I can just have 3D and then satellite, then you'll be the 3D base map. And let me see if it works. This might be a little bit too much. Okay, I think the base map is not working. So this is, I cannot show you right now. But you can try it on your computer. Just change it to 3D dash, and then you can actually have the video. It's actually graded on the terrain. It's not flat, so it's much cooler. If you want some better visualization, or you can do something like this. So we're gonna use the satellite base map, and then you can actually overlay these kind of things on top of the map. So again, this is a simple video, and overlay on top of this. And like I said, it's not difficult to understand. Just give me the URL, tell me the coordinates, and then just use add video. A couple lines ago, you can do this easily. Yes. Say that again. Yeah. Uh-huh. So this is basically at the map level. So for example, this is a 3D globe. And even a 3D globe right now, if you zoom in, right, it's still flat. It doesn't actually have the terrain. So in order to have the terrain, you will need to basically have the 3D base map. So this is where you use some other tiles. So for example, if I zoom into here, you know these are the mountains, but if you drag it, it still looks flat. The leg long, because you are specify where the video. Yeah, so basically doing all the conversion under the hood. So if you tell me where is the latitude and the longitude, and if you change to 3D globe, you will do the calculation to do the conversion. So that's basically some of the basic data type you can handle. And the next one to cover is PMTiles. Like I said, PMTiles is a relatively newer data format, but it's very powerful and it's very easy to use. Basically, it's just a single file hosted somewhere, and then I can consume that using the map. So take a look. So this is basically the URL to the file. So you can take a look at this one. If you go to this URL, it's actually the direct URL. So let me show you what it is. So if I copy the URL, paste into the browser, if you enter, it should ask you to download. So if you want to download, you can download it if you want to. So let's figure it out, try it out. So I'm gonna click download, and let me go to here. How big is this one? 194 gigabyte. Do you really want to download 194 gigabyte file? No, I don't want to. But take a look. All I need to do, okay, pointing to this URL, that one is almost 200 gigabyte. Now let me show you how to render the file. So this is basically global building footprint, showing like billions of footprints. It's a single file hosted just somewhere. And again, it's just a static file. You don't need a server to render the tile. It's already have the tiles embedded in the file. So when I'm clicking to this file, it already knows which tile I need to query. So basically, you can think about is the data structure can query the file and return the tiles easily. So you can think about inside it's just like a pyramid and can get the file for you easily. So take a look. So we're just trying to get the metadata of this file, and then you know the bounding boxes, the area that it covers, and then we can render the map here easily. This looks like a lot of code, but it's actually not. It's actually just specifying the style, like how do you want the layer to look like. And essentially what you need is this one, map.add PMTiles. So if you have the PMTiles, you host it here, give me, and then just add PMTiles. So let's see how we render this 194 gigabyte. And how long does it take? 1 second, right? So now we start, let me show you here. I can zoom in. Of course, your internet speed matters because it's requesting the tiles. Right now, it looks like this. So the more you zoom in, you're going to see more details. And these are all the building footprints for the entire globe with, I think, a couple billion buildings. And when you hover my mouse, you see also have the pop-up. And again, this is all 3D, so I can actually drag it. Right now, I don't show you the building height. You can render the height if you want to. I'll show you another example, but this just shows you the power of using this kind of open source tools. As long as your data in the right format, hosted somewhere, you can use this tool to render it, create it easily. So for example, the same thing, I earlier showed you the using Hugging Face, right? It's all free. So I can show you the same data set. Now hosting here, I can use this. And so let me, these are all raw street networks. So you can zoom in, you can look at the building footprint, you can look at all the data layer. Look at this. So this data, like very, very dense. It's all couple hundred gigabyte. I can render it just fine because it has the tile that you can request. Yes? Yeah, this one is actually hosted on Source Cooperative, but it doesn't matter. So the location doesn't matter. The file matters. I can download this file. I can host it on my local computer. It works. Say that again. No, you don't need, this one doesn't need the middle tiler. The raster need the tiler. Actually, this one also, PMTiles also support raster tile, but it's kind of a little bit slow. But this one, it doesn't, you don't need the server. It's just a tile, and there is no middleman. So actually, I'm consuming the tile. So basically, this tile can handle HTTP requests. So when I'm zooming, basically, think about here, when I have this map application, so when I'm zooming and zoom out, the information is being passed as a header to the HTTP request. So basically what is telling the this file is that, okay, right now I'm looking at this bounding box, this coordinate, and then give me the tiles. So the file actually is a static file, but you can send back the tile, and this is why I can render. There's no other middleman involved in here. So it's super powerful, really fast. And for example, there's some other data sets here. For example, some of the data set that created using deep learning, for example, agricultural field boundaries. And this looks a lot of code, but it's, like I said, it's just a style deciding what you want to look like. And so this one is showing here, right? These are all the agricultural field boundary detected using deep learning. And you can zoom in. Again, if the internet is slow, it might take some time to load up. But this is essentially what the PMTiles is being used for. The file can be 200 gigabytes, but when you are seeing the data, I'm not downloading 200 gigabytes. I'm only downloading a small piece within my map view, and you can see how quickly it is. So if you're working on some project, you generate some data you want to share with other people, PMTiles is a recommended format that you can use. Leafmap also have some tools that allows you to convert from GeoJSON to PMTiles, just one line of code, but we don't have time to cover here. And you can change, for example, opacity here. You have the outline, you have this, and everything is interactive, so you can also customize the color. The nice thing about PMTiles is not static, so the style, the symbology is not predefined, it's the user defined, and you can see, okay, I want this one as a blue color, you can change it. So all you need to do is come to this style here. For example, if this equal to something, I can use this color, use that color. If you don't define, it's by default just blue color or something like that. So this is what PMTiles. And next one, let me really show you like how easy it is. Maybe another example here. For example, this is another PMTiles. And okay, so this is really the same PMTiles. It's the free hosting here from this. I don't show you the URL. Actually, it's here. Overture buildings. Again, this one 200 gigabyte, but I can render it. Let me try again. Okay, it comes up just a little bit slow, but take a look. I have all the building footprints for the entire globe, and some of the building has height. I can render it on the map just essentially one line of code. So here I add PMTiles, give me the URL where it's being hosted, and you can specify the style, and you can have the template. For example, hover my mouse, you can see the height of the building. But if you don't like the color, fine, you can customize it. You can see here light blue, and then royal blue, and then light blue. You can change it easily. So for example, I want those high buildings changed to a different color. You can use a hex color code. So everything is very easy to customize. For example, I want to use maybe red color. Right, that's it. And now take a look. The map will be rendered based on the color that you selected. You see? Now those higher buildings is in red color. So how easy it is. So as long as you have the data, you can customize pretty much anything. So all you need to figure out, okay, how do I where do I host the data, and then get the URL, and then define how you want, and that's it. So super easy to do. And even better, you can use just one line of code, add overture 3D buildings, just one line of code. Create a map, add a base map, and add the 3D buildings, and that's it. So I guess if you use Python, you can easily do it. 4 lines code, I can have the 3D buildings for any location around the globe, and I can change the color, I can change the style, I can zoom into any location. So it's really powerful. So this really makes those data more accessible because it's in the cloud, it's cloud optimized GeoTIFF, and It's no longer just a GeoJSON or Esri shapefile load format because they are not cloud optimized. These are all cloud optimized, so you can just create these kind of cool maps with capitalized code. Lastly, I want to show you, I'm not sure if this works or not because earlier the map title doesn't work, but let's see. Anyway, it doesn't work right now, so it's because just the API key. But let me see if I can show you here. Map title, voila, map. Yeah, maybe I can show you something like this. Anyway, you can try it out yourself. Or even better, you can allow you to source a lot of data. So for example, this is, I integrate some functionality, allow you to source open data catalog. So they are open data from AWS, from Microsoft, from other third-party providers. And if they use the STAC catalog, you can actually source the data easily. So for example, I can find here, for example, let's say, okay, I'm interested in this area. You can just zoom to the area of interest. Let's say, okay, I want to look at the Bay Area. I want to find some satellite imagery. I don't know how, I don't know where to get started. So all I need is just create a map and then display the map. Then you can use the XStack GUI. So for me, I can just zoom to this area, just click search. It's a way to search the data available for this area without you having to write any line of code. And take a look. So now I have all the imagery covering this. It's kind of right now in a dark blue because there are lots of data available. And once you have that, you can see all the data available within the area. You can select a particular one, then just click display, and that's it. So you can search pretty much any geospatial data, and you can render it easily. So take a look. I don't have to write any line of code. Leafmap can help you source the data and then visualize the data, and then you can, for example, change things here. So there are a lot of things you can do. So allow you to either get the satellite data or you can get some semantic data layer. So for example, they say, okay, I'm interested in maybe in the lane cover change in Washington. So you can just zoom to this area and then I can select some of the open data. For example, I want the global lane cover data. So you can select this one. Just do a quick search. Okay. So now you're going to have, okay, there's this tile covering this area. Then you can select the tile. And after that, just click display. This one doesn't need the middleman, okay? So basically the data is in the cloud. And then there's a T-tiler endpoint. Passing through the endpoint, give me the tile and then render it on the map. So this one is a little bit slower. But you can see I have the lane cover data render on the map easily. And this is it. So basically you can source any data from the open data catalog. As long as they have the STAC endpoint allow you to source the data, then you can do this one easily. Okay. The last two examples is not working, just the API. So we can try it out later, but you can click the link here at the bottom. If you want to try out some of those, how I deploy to the web, you can look at the source code. Everything is open source. So you can see how the map is created. So for example, the example that I show you for searching the data for this one is this many lines of code, okay? But you can have a very complicated graphical user interface allow you to source data easily. So you can just create a map and then add the base map, add the STAC GUI, add the draw control, and then just turn this one into the web application. That's it. So it's super easy and straightforward. So try it out. You're welcome to adapt this one to whatever applications. So you can also create, for example, crop place maps. That means you can render the data. No, so it's not working. Render the data based on the attribute. So again, try it out and happy to take any questions. Yes. Point cloud is not supported yet, but maybe I have some other tutorial. It's not integrated into this one yet, but it's more like separate. So if you're interested in, you can go to the Leafmap website and then tutorial, and then just search LiDAR. You should be able to find some of the data for visualizing LiDAR, point cloud, one line of code, and then analyze the data. So you can click the link. For example, you can render the point cloud like this. It's still 3D, but it's not on top of the 3D globe. It's like a separate backend, but it's certainly feasible to render LiDAR point clouds with Leafmap. Any other questions? Yes. So Gmap use Google's engine as the compute backend to run all the computation. It can visualize Google's engine data. Leafmap doesn't use Google's engine. So as you can show you the example, like I have the data on Hugging Face, I have the data on GitHub, I have the data from AWS. It doesn't matter where's the data. As long as they use some cloud optimized format, I can pull the data in. But Leafmap can also render Google's engine data because it's just a web map tile. But Gmap is specifically designed for Google's engine. So if you don't use Google's engine, Gmap is pretty much not very useful. So if you use other cloud computing platforms, then just use Leafmap. So they look the interface looks similar, but the data where they're coming is varies. So Leafmap is more open, and you don't need a license. You can use it to do whatever you want. All right. Any other questions? If not, thank you very much for your attention. And again, the notebook is on the website. You're welcome to try it out. If you have any questions, you're welcome to post it on GitHub, and I'm happy to answer your questions 24/7, free service. Okay, thank you.